Okay, do your problem. Get your glorious carbs. You have the metabolism to deal with that right now. Enjoy it while it lasts.
You're all getting regular class A next week. One light day, one blue day. Tuesday, that's the best test, Wednesday through Friday of next week. Do you check your absences? That will be sent to all staff after 4 o'clock today. So we have the pledge. Two flags. Oh, have a great day.
Womp. This ain't even a bad one. Okay, it's nice. It's just, I want to see the full Gus Jordan. Get creative.
Usually I don't, but call it back. No problem.
Holly, the fraction problem?
Yeah, I did that, but the other ones I had to use fractions.
Oh, okay.
Yeah.
Fraction one looks scary. You just multiply it and it's good to go.
I got that part.
Maddie said she was going to be gone. And then, no, Riley. That's who's missing. Okay.
But now I have to go to sales.
It doesn't help my neck. We're back at the end.
It's like a whole office.
Mega test.
Please don't make any comparisons.
The Office is the most beautiful TV show.
Somebody got me in it. That was only live, but I tried.
I've watched The Office.
So let's stop blathering, and you have 4 more minutes If it takes you 10 minutes to do a single problem of this, I'm scared. Do the problem. You were quieter first semester.
That's because it was like me and Caleb, and that's it. Don't worry.
Congratulations. So it's gonna be interesting. Oh my God.
Oh, let's not do that today, Frank. You just gotta hang in there for 2 more days, bud. All right. 1, -1, 1, 3. -1, 2, -1, 2, 2, -3, 3, 8. Okay, I have a matrix. It already has a 1 up in that top left corner. Nice and easy to get going. So I work my way around the loop in Gauss-Jordan style. I'll use the 1 to knock out the x values below it. So how do I get rid of the -1? What's my directions? Yay! Someone said something. Okay, 1 plus -1, bye-bye. -1 plus 2, 1. 1 plus -1, ooh. 3 plus 2 is 5. So we get one of those magical Christmas lands where we get double elimination. Not only double elimination, but I already have 1 in that center column. If I want to get rid of the 2 at the bottom, I can use that 1, or I can use the -1 above it. Anyone got a preference? I like using the -1 just because it's less, I don't have to introduce a negative, which means it's one less thing for me to goof up. So I'm going to say row 3 plus 2 row 2s instead. So times 2 and add it, bye-bye. Times 2 and add it, 1. Times 2 and add it, 1. Times 2 and add it, 12. And we'll just nicely leave row 1 alone. Then we move on to column 2 with a 1 value and zeros to either side. Very easy to simultaneously knock out both of those and say row 1 plus row 2. We can say row 3 minus row 2. Subtract the 1, bye-bye. Still a 1. 3 minus 5. Oh, wait, no, we're adding. 3 plus 5 is 8. Boop, 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 boop. Still got my 0, 1, 0, 5 here. If I take row 3 minus row 1, or row 2, we'll got 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 0, 0, 1. 12 minus 5 is 7. And one last stop on the matrix drain. I'm going to say row 1 minus that row 3 that is now nice and isolated. We'll get 1, 0, 0, 0, 1, 0, 0, 0, 1. What is that called? 1's on the diagonal, 0's everywhere else. What's it called? Reduced row echelon form. And I will take 8 minus 7. 1, 5, 7. Make sure you write your answer. And like I had said earlier, we're going to run this as a Likert style because this doesn't have to be how you did it. I'm betting most of us did it this way just because it was set up pretty nicely from the beginning. But it's 5, 4, I got all the way there, and I got the work to back it up. 4, I got almost there. I was so close, I missed a negative in this one spot. I see exactly where my error is. Yeah, I done did a goof. I made 2, 3 tiny arithmetic errors, or maybe I just missed my negative on an entire row, something like that, where I'm obviously wrong, but I got the general process. 2 is even the process still eludes me. I'm struggling. I tried to do row operations, but it went nowhere. 1 is I attempted something that looks like a matrix in math. And 0 is I didn't even do that. I wrote down the problem and cried. Okay? So, Likert scale. Yes, ma'am. Ruh-roh.
So I thought everything was the same, but after here, I did something completely different and still got that, and I wanted to know
Yeah.
how.
You just drove a different route. That's fine. You just took a different road. Remember, this is an example of what it could be.
I don't know what
Got there. How much you want to bet? I'm going to say missed a negative. Like, that's just kind of how it goes. It was 5, row 1, row 2, add 5, check, row 5, minus 2, row 1s, minus 2 of those, minus 2 of those, 5, negative 1, minus 2 of those, 5, minus 2 of those, yep. Row 1, minus row 3, 1 minus 3, minus a negative. Missed a negative.
What do I get?
Negative 1 minus a negative 1 is 0. But hey, 4 out of 5. Yo, do we feel like we know what we're doing? We're just really mad that it's not going perfectly. Okay? Well, kind of. 6.1 and 6.2 are really stuff from Algebra 2 that you never got to. And we show you this stuff because matrices are used a lot in discrete mathematics later on. They have applications in different places. Particularly, we're going to do partial fractions, gearing you up for calculus. And sometimes the systems in them get really big. That's why we have matrices next to that. Just because people are asking, and I want to make this clear. Next week, last lesson is Monday. Review quiz number 13 on Tuesday. You have voted for a 1-day final, 20 question. You are, unless you schedule something differently with me, you need to come in for either block 1 on Wednesday or block 2 on Thursday. Not both. You come in for one or the other. If you don't show up on Wednesday, I ain't marking you absent, I'm just assuming you're coming on Thursday. If you don't show up for either, all right, now I'm going to mark you absent and wonder where the crap you are. Okay? If neither of those blocks works, maybe you just got a bunch of other stuff going on. Maybe you want to, because I'm flexible about this, maybe you want to do your final, maybe you got an open block during white 3. So you want to do your final then instead, so you can focus on other stuff on Wednesday and Thursday. Fine by me. You just got to let me know before Wednesday. Okay? So those asterisks, those are open for everyone. If you're someone who regularly takes a long time with your tests, if you usually take longer than most of your peers with the tests, I would recommend do yours on the 25th instead, since there's an open block before it. Just come in early. Okay? Like 9:54, the bell rings, and here we go for the final. Come in at 9. Okay? Yes. Not at all. I ain't looking for you. Okay? We're flexible. In fact, that's how it's supposed to be with math classes that are every day. Because you're not supposed to have 3 core finals on that first day. So you're supposed to, by our high school policy, be allowed to reschedule one of them. Yeah?
So, is it missing 10 classes or 10 or more? Because I'm always, I'm really confused.
Um,
10 classes, I'm not sure about not passing, but I'm just.
The cores were, English,
grading attendance is stupid. I ain't marking anything.
well, there's a different, I thought it was just those 3.
Okay?
I'll look.
Yes.
That's why we take like the social studies class in middle school.
Math, English, science, social studies. Okay? So, I'm just saying, that's the final schedule. Those are the 2 blocks you're scheduled in here. If you normally take a long time, probably better to do Thursday and just come in early. Remember, you get the review and whatever you can cram on it, nothing else. You come in with your review and a calculator. I'm going to have you reset the calculator right in front of me, and then game on. Okay? If you're that desperate, go ahead, have at it. I don't care anymore. Like that. Honestly, I'll be honest with you. I did the teenager thing. I was worried about a grade once. I attempted to cheat. You know what it did? It made me accidentally study. Because I was writing it in really, really tiny script on the side of the central silo of a clear mechanical pencil.
That is so smart. How are you that smart? I would not have thought of that. I'm like now, that is.
But all it did was force me to study because I had to write it.
Okay, but.
Okay? So, it was just a couple of formulas. That teacher didn't let us have formulas. So, you get the review and whatever you can cram on. Okay? No.
Well, last time.
No.
But last time you let me take
If you tape it down,
Yeah.
so it stays on there.
Yeah, so as long as they can't like there's nothing.
It's not going to be like your review is an advent calendar where you can flip it open and have more stuff.
No, but like when.
Okay? Yeah. Like some folks just have certain notes on sticky notes in their packets and just want to move it over to their review, fine. You want to put the unit circle on one of the sticky notes and cram that into a space that you didn't use as much space on that problem. Okay, fine. But tape it down so we're not getting weird, okay? No, do not be that kid that prints out the review on full legal size paper and comes in with what looks like poster board. I've had kids do it. I had a kid show up to my geometry final with poster board written out. So, yeah, it really should be low stress. If you've looked at the review by now, you know this is just the stuff we've done. Like, it's middle of the road, sea-level problems. It's not a big deal. You get to show yourself how to do it. You'll be fine. Okay? Getting back to this, there was something about matrices that you weren't shown. In Algebra 1, you learned basic scalar multiplication. Scalar multiplication was supposed to be used for dilations in geometry, where you'd have a coordinate matrix for your triangle, and you'd say, okay, dilate it, times with a scale factor of 3 from the origin. Well, I would just multiply all of those things by 3. Easy peasy. What we haven't done yet is multiplying a matrix times a matrix, because that gets weird. So first of all, do you remember what all these little letters mean? All these numbers, subscripts. Look at the number and look at its position. It's row and column, okay? And that's exactly how we're going to end up multiplying. When I take this row by column matrix times this row by column matrix, I'm going to take these rows times those columns to get that element. So my matrix, if like this is element A sub 2, 3, I would take the things in row 2 times the things in column 3. I'd add them all up, and it'd get me that number. Okay? So we're going to practice this by writing it out so you can see what's going on. But then, as we get a hang of it, you'll see if you just finger track these rows, these columns, you go this times this, plus this times this, plus this times this, add them up. Throw the number there. It's actually going to be faster to do them by mental math and just finger track it. Yes, you can just plug in this matrix into A, this matrix into B, and say A times B. I'm telling you it's faster to do the actual multiplication by hand, mental math, than it is to even type it in. It is faster, okay? So, down here at the bottom, they give you, see how it's kind of set up sequence and series style? But what they're saying is, if I have that dot, 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 meaning this goes for however big the matrix is. If I want to find element 1, 1, I am taking the stuff in row 1 times the stuff in column 1 and adding them. So I would multiply these, I'd multiply these, I'd multiply these, I'd multiply these, and I'd take all of those products and I add them together and it would get me this number. So if I wanted this, this is row M, column 1. I would take this stuff times column 1. Okay? Row by column. Nope. Because each of my matrices is labeled, matrix A is called a row by column matrix. See, here's the thing with matrices. Because they're an organization of data, matrix multiplication is not commutative. Every other type of multiplication that we have come across, 5 times 3 equals 3 times 5, right? Matrix A times matrix B is not B times A. This is the first instance of that you have encountered. Matrix multiplication is not enclosed under the commutative property. You are starting to get into the realm of discrete mathematics. Okay? I just want to walk you through the basics of it because it's used an awful lot with statistics, discrete math, engineering. I know some of you have aspirations of that. Also, I hate standardized tests, but it's on ACTs. Okay? It's that grab bag. It's that 10% of questions from everything past Algebra 2 that you don't know what you're getting into. It shows up on ACTs, I want to show you. Okay? It's also really nice when you have data in tables and you're trying to find specific information. Works nice for that. So, first up, you have to tell me what the dimensions are. Row by column, this is a 2 by 2. This is a 2 by 3, right? Row by column. The first thing to check is whether it is legal to multiply these two matrices. Like, if I got just two numbers, 5 and pi, I can multiply those. You can't multiply every matrix pair together, only some of them. Because when I say A times B, that's a 2 by 2 times a 2 by 3. To check if it's legal, these two got to match. Okay, I'll show you, because B times A is not possible on this one. Okay, but I'll show you why it doesn't work. Like literally, you're trying to multiply a term times nothing. Have you ever missed a value when you've typed in your list for all of our regression stuff, and then your calculator says error dimension mismatch? That's what's happening. Okay, you're going to try to multiply something by nothing. So A times B is legal. So I'm going to write those out. That's 3, -1, 4, 0 times -2, 3, 0, 5, 6, 1. Additionally, the 2's in the middle says that this works. The ones on the outside tell me 2 times 3, 2 by 3, is going to be my answer matrix. My answer matrix will be a 2 by 3. Now I'm going to write mine big here for our first example, and I'm going to show you where the different elements are, breaking them up like this. Row by column. The inside parts of the dimensions, when I say A by B, have to match to say it's legal. The outside parts of the dimensions tell me what my answer will be. Okay. So if I'm trying to do this spot right here, what element is that? Row 1, column 1. So I will take row 1 stuff times column 1 stuff. It's row 1, column 1, so take row 1 times column 1 to find this element. We get the corresponding numbers. 3 times -2, -6, the corresponding elements, the first terms, the second terms. -1 by 3. There you go. Smack those two together. That's your answer. So -9 goes there. I have the sum of the values. It's a -6 plus a -3.
Oh, I thought you just do 3 minus 1 minus 2 plus 3.
No. Products. You multiply the corresponding elements. First term times first term. Second term times second term. Third term times third term. And add them all up. Okay, then I'm over here. What element is it? Row 1, column 2. So take row 1 stuff times column 2 stuff. Okay, 3 by 0. And second term negative 1 by 5. Add them together. Once you get used to it, it's like, how many of you can do weird finger tricks? Like, you can do the cat's cradle thing. How many of you, dude, how many of you can play a piano? How many of you can type over 120 words per minute? Okay. Okay. How many of you are in band? Okay. Dear God, moving your fingers like all along a clarinet or something? Like, I can't do that. Okay. Oh yeah, clarinet. This one. Yep. I got like a L-shaped like mouthpiece so I can play my clarinet sideways.
It's like that one Mission Impossible where it's actually a gun, you know?
So, I'm saying, you have had to learn dexterity for different things in your life. Think about you just right now writing. Think about all the way back to pre-K, how many of you jammed like this? You know, like the full fist grip on your crayon, your oversized, like, yeah. Yep.
Maximum stability.
So you have had to learn how to do different things that seem very complex, but after you get the pattern of it, it's not a big deal. This is not a big deal because row by column means row by column. Multiply, multiply, add them together. Okay, that's it. That's all it is. So 3 by 6 is 18. Negative 1 by 1 is negative 1. 18 plus a negative 1. Okay, that's it. That's what it is. I come down here. Now what am I in? So row 2 times column 1. Multiply the corresponding elements, first with first, second with second. Negative 8 plus 3. Or 0. Good thing I didn't write it. Should have waited. No, it actually does matter because y'all could get it.
8 points in 3 days. Me and Connor have achieved that before. We get a lot of points.
I'm thinking negative 8.
Yeah.
That is not a teeter-totter. That is such a...
But that was just a simple statement.
Okay.
But the tone when you said it.
Y'all, I want to get through this and start 6-4 today. We're on row 2, column 2. 0 plus 0. I'm on element 2, 3. I'm on row 2, column 3. 24 plus 0. That's it. That's the answer. Okay. Now,
20 questions of this.
I know you got more space here than I do. I'm just going to erase this and start BA. Okay. Because now I have a 2 by 3 times a 2 by 2. The insides don't match, so it's not possible. But I'm going to show you why it's not possible. Okay? Start with that very, very first term. Just right here, this is element 1, 1, right? So take row 1, column 1. Row 1 times column 1. And I'll get a -6 plus 0 plus no, you can't just shove a 0 in there. You can't just add a new row of zeros because you feel like it. There is nothing there. This is just like trying to, remember when we did the tangent of pi over 2, and then we did the arctan of it? I can't put undefined into something. It's not a valid input. I can't take 6 times, like, there's nothing there. Since there's nothing there, I can't even complete the process. So we got AB for BA. You just say, no, it's not possible. It doesn't exist. You literally can't multiply B times A. Okay?
Stop it. Stop that.
It's like that one meme was.
Okay, you're good.
See, you can't catch myself. I'm making fun of it.
It'll be taking 17 years.
I'd say more like
1 and 2, please.
12.
AB and BA, if possible.
Yes, it's possible.
AB and BA, if possible. Skill issue, dude.
I'm sorry that I don't write. I think it's the former. Just kidding.
There you go. Is it not? Did you also get everything?
Is it? Okay. BBA, -4, 0, and 18. -4 and 18.
Wouldn't that be 27? The 9.
Oh, 27. Yeah. I'm tired and they're loud. Your next one, column 2, so 0, 0, 9. 3 by 3.
Oh, okay.
Yeah, you just got to slow down with all. You're doing the process right. You just got to slow down and double check our arithmetic. Oh, stop it, Frank.
We have to like show by our just like put them out.
I would do this and then say no.
No.
It's a 2 by 3 times a 2 by 3. The middle dimensions don't match. Can't do it. Likewise, what?
Where do I go from here? Because I did these. Oh wait,
But
nope, I did.
That's why you write out your dimensions. If you're doing A times B, that's a 2 by 3 times a 3 by 2, right? 3's being the same means it works, means I'll have a 2 by 2.
Shut up. I got scared.
Okay,
I got really scared. That's okay.
yes.
How is it 2 by 2? Because if you multiply the row by the column, then the row has 3.
And you add all that up for a single term. Row 1, column 1.
Wait.
Row 1 times column 1 makes element 1, 1.
Wait, I'm lost. Because on this one we did that. Oh, I guess this works. That one.
You're forgetting the add them up part. All of this makes a single number.
Okay. But I thought I had to like multiply it right. Oh, I multiplied those two and multiplied those two and multiplied those.
And then add it
And,
all
then
up.
add them, and that's the same. Okay,
Yes.
I'm sorry, you know her.
Okay, so 1A, AB and BA don't work? Yo. Most of us are conditioned to read left to right, up to down, right? Most of us are conditioned that way. That's why I said most of us is some people might not have native English language. So, it is possible that other cultures have different language structures where they read vertically, where they read right to left instead. So, because we are trained that way, for most of us, it's going to be difficult to do AB, then BA, if we're tracking backwards. If you're tracking this way and then down this way, because we're not used to that motion. So if you are trying to do these by the minimal amount of writing possible, which is usually what kids want, I'd recommend at least writing out the problem. Okay, do A times B. 2, 0, negative 1, 0, 9. Just so you can still track left to right. I would do B times A. Just so you can track left to right. Also, it helps you to write out your dimensions. This is a 2 by 3 times 3 by 2. My middle dimensions match, so I know it's legal. My outer dimensions tell me that my answer will be a 2 by 2. Again, I don't need those lines to divide up where the elements are going to be. I'm just doing that to help guide me. And then, as I roll through, row 1 times column 1. Negative 4 plus 0 plus 27. Row 1, column 2. So row 1 times column 2. 0, 0, 9. Frank, you stupid piece.
Right, just because, getting the top.
Frank is having issues today. Like it started yesterday afternoon where the calibration was switching in the middle of writing.
No, she literally does this all the time. I don't even. She gets mad at Ava when she doesn't do that.
So anyway, how about 10, 7, and 9? How about 0, 0, and 3? Cool? Like, is this coming out okay now?
Yes.
It sounds complicated, but once you get the pattern of it, it's fine. It's like when you learn a new mini game on Mario Party. Okay? Like it's weird the first time you do it, and then after that, oh, okay. Next one, see if we can do it without all the visual tracking. -4 plus 0. 0 plus 0. 6 plus 0. There's my row 1. Move on to, we're in row 2. Go to 2 plus 0. Row 2 columns are going to be 0 plus 0. Are going to be -3 plus 0. Go down to row 3. -18 plus 15. 0 plus a -21. 27 plus 3. Okay. So element 1, 1, take row 1 by column 1, a -4 plus a 0. Row 1, column 2, a 0 plus a 0. Row 1, column 3, a 6 plus a 0. Okay, you see where that visual tracking comes in. I have had kids in the past who, they got a ballpark for their own size of writing. They'll take a note card and they'll cut out like a rectangle for where a row or a column would be. And they physically track it with all of the other information gone. Or they highlight the rows and columns as they're working. Okay? You do what works for you, but you have to find a way. Yo, there's a crap ton of numbers up here. This looks like, you know, the alphabet cereal box exploded on the floor. There's just stuff everywhere. You're going to have a method of organization for it. Okay. Come on. No. Not with him in the room. Go over to 2. I don't want to have to kick them out because that's going to end up happening if we do that problem. Go over to 2. Just not in the mood for it. So what this can be used for is this whole row by column thing. It also determines the labels on things. See, these are both what size of matrices. Like the data, don't look at the labels on the sides. Look at the data. What is the size of the matrix? They're both 3 by 3. So I can do A times B or B times A, no problem. But which one do I do to answer the question? Okay? So, first of all, row by column. What are the rows of this matrix? Month by, well, read the problem. They're selling laptops. This is how much the different models cost in the different months. This is month by model. And this is model by month. Oh, well, they both said the same things. What is each matrix about, though? What are all these numbers? Read it. The number of laptops that a company sold versus the price during those months. What? Is there X-lax in it? Okay. Thank you. This is number sold. This is price. So, the question asked is, which model generated the most income in the first 3 months? So, when I do this whole row by column thing, this is going to get me, it's not going to distinguish by model. At the end, it's going to go month by month. It's going to tell me the January price with the January number sold. The January price with the February number sold. The January price with the March number sold. Well, it doesn't make sense to compare the January price with the March number sold, right? So those entire elements of our answer matrix are useless. This is why the labels matter. I just care about January price with January sold, February price with February sold, March price, March sold. That's going to get me how much was sold in that month. The question asks for which model generated the most over the 3 months. I don't want A times B. I want B times A so that I'm going model 1 price with model 1 sold. Model 2 price with model 2 sold. Okay? Since if they asked, determine which month had the most sales, I do A times B because I would want the months to be my labels. They're asking which model sold the most. So I'm going to do B times A so that I end up with models for my labels. So I'm going to take this one, which is row by column, 3 by 3. Row by column, 3 by 3. This is model by month. which is 650, 575, 485, 800, 700, 775, 900, 1050. I'm just writing them in order because if I try to multiply this times that, my finger tracking gets messed up. I'm writing them in the correct order. 925 times this matrix A says 3 by 3, and it is month by model. This tells me it's legal. This tells me what my answer is going to be. Just like we did before, the row by column and row by column, the outer dimensions are going to tell me what my answer is. Not just in terms of the size, but it's also going to determine the labels for it. 150, 250, 550, 200, 625, 100, 600, 100, 350. Okay, I'm doing them in this order because it tells me my answer matrix will be a 3 by 3. Frank, you piece. Come on. You only got to hang in there a few more days. After that, I don't care. Okay, it's going to make a 3 by 3 matrix. What I'm saying is these outer dimensions, they don't just tell me that my answer is going to be a 3 by 3, they tell me the labels for it. They tell me this is going to be I am so sick of this smart board. I am so sick of working with technology that's older than my students. But by all means, let's have the new principal come in at almost 200K. Yeah. I'm not joking. This is the exact same model of smartboard that I first did for my junior field practicums in 2006. October.
You know what? I was alive by then.
You know, I was like, what, 8 months old?
Okay.
I was in the hospital.
So this is well, stop, please. Remember that the rows are coming from matrix B. Matrix B is about prices. So this is model 1 price. This is model 2 price. This is model 3 price. My column information is coming from matrix A. Matrix A was about the number of sold. This is the number of model 1s sold. the number of Model 2s sold, the number of Model 3 sold. This, when I multiply them together, it puts the sum total of all 3 months together by these labels. Because watch what happens when I want this element. I'm going to take all of the Model 1 prices times all of the Model 1 amount sold across January, February, March. January, February, March. I'm going to take the January sold, or the January price with the January sold, the February price with the February sold, the March price with the March sold. That's how I end up multiplying them together. That's why that one matters. So grab a calculator because I don't trust myself right now. Okay. That means using the Model 1 prices for the Model 1 amount sold, the combination of January, February, and March was this much money. Now, think about those labels, though. If I come over here, what is it saying? The labels. The number of Model 2 that I sold with the price of Model 1. That would be like me saying, how many PS5s did I sell using the Switch cost? You don't, right? You just don't do that. So that means these ones don't matter because they're going to give me data that doesn't make sense in the context. I just need the ones on the diagonal because those match Model 1 with Model 1, Model 2 with Model 2. This element says Model 2 sold with Model 2 price. So I take Model 2 price with Model 2 sold. Someone confirm? Uh-oh. Okay. Then I want the Model 3 sold with the Model 3 price. Now the question is, did you do all the individual multiplication on the calculator or did you type in matrix A and B? Okay. Which is also why when we come to these type of problems, when it comes time for your daily check on Monday and your quiz on Tuesday, if it's just find A times B and B times A, and they're nice numbers, I'm going to say, show your work. But if it's a context problem like this, by all means, use a calculator if you want. What I want to see is, I want to see this, and then your answer. Because this shows me you understand why you're multiplying them in that order. Show me you understand the labels of the matrices and that you are going to have a comparison of model totals instead of a comparison of month totals. Okay, what was the last one? Yeah? Okay. And by the end of the problem, it should make sense. I mean, look at Model 3. It's more expensive than the other ones. And grand total, they were selling about as much as the other ones. So if I'm selling about the same number and the prices are all higher, then it makes sense it's probably going to be the biggest total. Talking. Go down to number 3, golf.
I love golf. How is that a point?
It's just the sum total of the last 20 minutes.
Yep, one point.
Okay. So look at the first one. What is the size of the matrix? What are the rows and columns labels? Company and because this entire thing is about type. Or not type, quantity. The second one is a 4x1. It's the club type by the value. Here, number of club, there you go. So if I'm trying to multiply these together, do I do A times B or B times A? If I'm trying to find out, determine which company's daily production has the highest retail value. Right? Which company has the highest retail value? I want company and value to be the label at the end. So I have to do A times B to answer their question. In this case, I also have to do A times B because that's the only legal way. They're not always going to be that obvious. Usually these are square matrices, 2x2, 3x3. Okay. So this tells me it's legal. This tells me that my answer is going to be a 2x1. And that 2x1 is going to have the labels of company and value. Okay, that's what I'm getting at here, is the row and column aren't just about the dimensions, they're also about the labels of the matrix. So, I'm going to take this row times this column, row 1, column 1, to make element 1, 1. Sorry, I'm getting heated with Frank over there. I'm just really sick of his crap. I'm really, really, really tired of fighting with ancient technology while our district spends its money elsewhere. We'll hire more police for schools, but we won't get a smart board that works. What was that amount? $900. Okay. Element 2, 1. Row 2, column 1. Confirm? Okay. Okay, that's what I want you to get on this. Like, honestly, on these, I got no problem with you typing it in as matrix A and B in your calculator and then just hitting the button. But you have to know which elements matter. These are small ones. But what happens when it's a 4x3 and a 3x4? Both AB and BA are possible. Which one do I do and which elements do I do? Okay? That's what we want to get at this. It has its uses. Yeah. Correct. Yeah, it was the only way I could legally multiply them together, but it was also the only way I was going to answer their question. Whew. All right. The short version of this is that you can turn equations into multiplication problems. I ain't going to bother with it. You would just solve with Gauss-Jordan, like we were doing. And I had said we weren't going to do inverses. If you go on to discrete math, you'll need it, but I double-checked with Spear because we have to triage some stuff at the end here, and he said that he didn't mind if we cut inverses out. So, I'll cut that out and go to 6-4. He briefly touches on them there. It's more of a discrete math, stats and engineering thing. All the way to 6-4. Okay. All the way to 6-4. Now, I want to do stuff with yeah. Okay. So in any of that blank space before 6-4, in any of that blank space before 6-4, I would like you to do a basic arithmetic problem without your calculator. Oh, no. Sorry about that. Go. Yeah. No calculator. Y'all passed elementary school, right? Ow. No calculator. I'm waiting.
I don't know if that's what this is.
390, 115, 75, 75, 15, 16, 17 over 3,900. Yeah.
27 plus 27 plus 90, 117.
So it would be 1,600.
I'm trying to do this.
1,000.
No, shut up.
1,000.
Shut it!
Wait, what? Well, hold on. I shut up. I did shut up.
The fact that it took the entire room shouting it a second time.
And you guys have an 8 plus for food. Yeah.
Oh, that was a really good word.
Okay, we all remember common denominators, right? So we would have a 1,500 plus 90, 27, 117 over 3,900, making that 1617 over 3,900. So 5, 3, 13, 14, 15. They are divisible by 3. So that's 1,300, 3, 15, 500, 117, 40, 39, 539.
You add
1 plus 6 plus 1 plus 7 is 15. Since 15 is divisible by 3, that number is divisible by 3. That's elementary school. That's divisibility rules.
Where was this in elementary school? Because I'm not taught this.
I don't know. They had me do this kind of stuff 2 grades ahead of time because I was trying to be punished. They tried to punish me with math, and now I teach math. So, like, y'all, I was in the principal's office before lunch first day of kindergarten. I was that kid. I threw Jen into the coat rack. You know, the one that's bolted on the wall? Yeah. So, I don't know if it goes any lower than that. I don't think it does. So, okay. So then you probably also remember how to do stuff like go.
I know I have an expression evaluation calculator that will do that, but I don't think.
It won't simplify the expression for you. It'll only evaluate. Get cracking. Okay, if you like these, I think you'll have fine time with the last section. I want you to combine these. They actually do smell pretty good.
Wait, did I just Oh wait.
You forgot your middle term.
Yeah, I know.
First outer and last.
You don't need to laugh.
There we go.
And if you write everything out, looky like this, and then you combine like terms. What's that? 175 negative 4 5 plus 2. I'm just seeing if you can get here. Are there factors of negative 8 that add up to 2? AC method. Who do what? I have to bleep my denominator? What? Oh. No, this is a simplified version. Leaving it factored is how you would then find asymptotes for graphing these. We're not going to be graphing anything. Okay, this is now, what's that? Plus 1, minus 1, and 5, that's 2x, 4x. This is x plus 2x minus 1. If I put it in factored form, does anything cancel out? Yep. Okay. So I wanted to bring that up because I ain't starting it until Monday. What we're going to do is work backwards. The only way that I could have gotten here is, how does this factor?
X minus 5 and x plus 4.
So I had to have something over x minus 5 plus something over x plus 4, and I added them together. I don't know what they are. Right? I don't know what they were, but I do know that I had to get common denominators. And then you end up with an expression on the top that equates to a two-variable system. You solve the two-variable system, then you know what A and B are. That's how. Now this is example 1 with a two-variable system. That's why I said we're going to leave it for later, because we will get to 3, 4, 5 for sure. I don't know if we'll get to the examples that go to 7 and 9 variable systems. But since I'm up here fighting with Frank and I just don't like how this is going, I wasn't going to try to force it. I just wanted you to say, y'all know how to make common denominators, right? You know how to do that. This is doing that plus system. Okay? It's not that big a deal.
Reminder, if there is anyone who is planning on doing their final a different block besides maroon and white one scheduled blocks, you gotta come talk to me. Let me know ahead of time.